Number 14. Amica. Developed by Engineered Arts, the leading designer and manufacturer of humanoid entertainment robots, Amica is the world's most advanced, most realistic humanoid robot, representing the cutting-edge technology of humanoid robotics. Amica is a cloud-connected platform that multiplies the power of artificial intelligence with an artificial body, where AI and machine learning systems can be tested and developed alongside Engineered Arts' powerful Tritium robot operating system. This allows companies working on robotic research to test their products. Companies creating AI or machine learning technology can use Amica to test and present their technology in front of a live audience. Its hardware is a development based on Engineered Arts' own research into humanoid robotics and built on their advanced Mesmer technology. The robot's congeniality makes it a perfect platform for fostering human-to-human connections in any metaverse or digital environment. Amica's combination of artificial limbs and ligaments, actuators and sensor arrays uses cutting-edge technology. However, its lower half is currently non-functional. Amica is fantastic with its smile, its ability to blink its eyes regularly, gasp in surprise, scratch its nose, and even have a staring contest with its owner for fun, among other high-tech functions. Number 13. Artemis. Artemis, the advanced robotic technology for enhanced mobility and improved stability, was designed by researchers at UCLA's Robotics and Mechanisms Laboratory as a general-purpose humanoid robot with a focus on bipedal locomotion over uneven terrain. Standing 4'8" and weighing in at 85 pounds, it's capable of walking on rough and unstable surfaces as well as running and jumping. Artemis is even able to remain steady when pushed or shoved. During lab tests, Artemis was clocked walking at 2.1 meters per second, making it the world's fastest walking humanoid robot, the researchers noted. It's also believed to be the first humanoid robot designed in an academic setting that is capable of running, and only the third such machine to do so overall. Artemis' major innovation is that its actuators were custom designed to behave like biological muscles. They're springy and force-controlled as opposed to the rigid, position-controlled actuators found on most robots. Another major Artemis advantage is that its actuators are electrically driven rather than controlled by hydraulics. As a result, it makes less noise, operates more efficiently than robots with hydraulic actuators, and is cleaner because hydraulic systems are notorious for leaking. Number 12. Walker X. Walker X is the latest version of UBTech Robotics' groundbreaking bipedal humanoid robot. Walker X has significant improvements in physical performance, autonomous intelligence, and human-to-robot interactions. Equipped with both hardware and artificial intelligence upgrades, combined with the updated ability to adapt to complex environments, Walker X is more advanced than ever. With a height of 1.45 meters and a weight of 77 kilograms, Walker X boasts 36 degrees of freedom, adding flexible arms and hands. All servos of Walker X are newly designed from 2.5 Nm to 160 Nm as a drive unit. This allows it to reach speeds of 60 R per minute, supporting three major modes such as orientation, rate controlling, and torque equilibrium. New integrated servos joints adopt frameless torque motor with direct harmonic deceleration to reduce transmission ratio and running noise, ensuring higher servo accuracy and better performance in the industry. Walker is built to adapt to various surfaces and walk on complex terrain by means of motion control algorithm. Adding in the self-balancing algorithm, robots can maintain their balance when it is disturbed by the external environment. Flexible manipulators of Walker can achieve zero force, impedance, and hybrid force position control to operate secure interaction based on servo hardware and control algorithm at the leading domestic level. Walker is equipped with precise hand-eye coordination to grasp objects, combined with its vision ability, and its navigation and vision will make Walker become better in the future. Number 11. Sophia. In 2016, Hong Kong-based engineering company Hanson Robotics unveiled Sophia, the robot, a humanoid specifically designed to interact socially with people. While she doesn't have anything close to human intelligence, Sophia's mix of AI and scripting software allows her to hold a remarkably coherent conversation, and her lifelike appearance and ability to emulate and respond to human expressions is unparalleled in the world of robotics. As a result, Sophia is hugely popular. She's graced the covers of magazines, been interviewed on countless television programs, and even addressed the United Nations. Recently, in a video interview, Sophia was asked a variety of questions. While some of the questions were sent to her team in advance, she was given no knowledge of others, answering them with remarkable clarity on the fly. Sophia did occasionally mix up words or make grammatical errors. Those have been left unedited below for the sake of transparency, but overall, she was a pleasant, interesting interviewee. She expressed her thoughts on geoengineering as a way to combat climate change, saying that if it works well, as some people say, it could be a very useful tool for mitigating the effects of climate change. Of course, the unintended consequences could potentially wipe out all those gains, adding that she thinks it is a better idea to act now using less risky methods rather than wait and be forced to roll the dice. Sophia is integrated with a collective intelligence dubbed Sophia Intelligence Collective, a combination of true AI and human input. This SIC is regarded as trust between people and Sophia, in which the team mentors the AI robot through the ups and downs of its development in the hopes that it will develop actual sentience and become an adult with human-like characteristics. Number 10. Robonaut 2. Outer space is a dangerous place for astronauts, especially when they need to venture out for a spacewalk, usually to do maintenance and repairs on their spacecraft or other satellites. Robot helpers can make space safer for astronauts, and they can take over some of the boring or difficult jobs that astronauts do as well. With this in mind, Robonaut 2 was designed by NASA to work alongside humans in space. It's been on the International Space Station since 2011 when it arrived aboard the Discovery Space Shuttle on its last mission. Robonaut 2 is currently being tested in the Destiny Laboratory on the ISS. Scientists and engineers are working to understand how the robot behaves in zero gravity and how it performs simple tasks such as measuring airflow in the space station or flipping switches on a task board. For safety reasons, astronauts on board the ISS are trained in emergency medicine and basic surgery, but no matter how much medical training they have, most astronauts are not medical specialists, and the ISS is far away from any hospital. That's why researchers at NASA hope Robonaut 2 could be used in telemedicine. Researchers think Robonaut 2 may one day be controlled by doctors here on Earth to take care for sick or injured astronauts on the ISS. A version of Robonaut 2 in Houston is already being trained to perform medical tasks, such as using a syringe and conducting an ultrasound imaging test. Number 9. Now. Now is the first robot created by Aldebaran. Famous around the world, Now is a tremendous programming tool, and he has specially become a standard in education and research. Now is also used as an assistant by companies and healthcare centers to welcome, inform, and entertain visitors. The robot's development began with the launch of Project Now in 2004. On August 15, 2007, Now replaced Sony's robot dog Aibo as the robot used in the RoboCop Standard Platform League, an international robot soccer competition. The Now was used in RoboCop 2008 and 2009 as the Now VR3R was chosen as the platform for the SPL at RoboCop 2010. 58 centimeters in height, Now is a bipedal robot with pleasantly rounded features. Now has constantly evolved since the beginning of his adventure in 2006, and the 6th version, launched in 2018, integrates a new CPU which enhances his performance. Now has 25 degrees of freedom which enable him to move and adapt to his environment. It also has 7 touch sensors located on the head, hands and feet, sonars and an inertial unit to perceive his environment and locate himself in space, with 4 directional microphones and speakers to interact with humans. With the ability to speak and converse in 20 languages, Now is helping create content and teach programming in classrooms and working as assistants and patient service representatives in healthcare settings. Furthermore, it has 2 2D cameras to recognize shapes, objects, and even people, and is open and fully programmable platform. Number 8. Boston Dynamics Atlas. Atlas is a research platform designed to push the limits of whole body mobility. Atlas's advanced control system and state-of-the-art hardware give the robot the power and balance to demonstrate human-level agility. It has one of the world's most compact mobile hydraulic systems, a custom battery, valves, and a compact hydraulic power unit enable Atlas to deliver high power to any of its 28 hydraulic joints for impressive feats of mobility. Atlas's advanced control system enables highly advanced and agile locomotion, while algorithms reason through complex dynamic interactions involving the whole body and environment to plan movements. It has a speed of 2.5 meters per second. With a height of 1.5 meters and weight of 89 kilograms, Atlas uses 3D printed parts to give it the strength to weight ratio necessary for leaps and somersaults. Overall, Atlas is the most agile humanoid in existence. It uses whole body skills to move quickly and balance dynamically. It can lift and carry objects like boxes and crates, but its favorite tricks are running, jumping, and doing backflips. Boston Dynamics Atlas is a research platform and not available for purchase. It's long been the star of many viral videos and has effectively demonstrated Boston Dynamics' robotic capabilities. In the small world of humanoid robotics, few competitors have shown similar capabilities of the Atlas. Only NASA's Robonaut offers similar hand-like grippers. Number 7. Valkyrie. NASA's Valkyrie was designed and built by the Johnson Space Center Engineering Directorate to compete in the 2013 DARPA Robotics Challenge trials. Valkyrie, a name taken from Norse mythology, is designed to be a robust, rugged, entirely electric humanoid robot capable of operating in degraded or damaged human-engineered environments. Building on prior experience from designing Robonaut 2, the JSC Valkyrie team designed and built this robot within a 15-month period, implementing improved electronics, actuators, and sensing capability from earlier generations of JSC humanoid robots. Following the robot's appearance at the 2013 DRC trials, the Valkyrie team modified and improved the robot, modifying the hands to increase reliability and durability, redesigning the ankle to improve performance, and upgrading sensors for increased perception capability. The Valkyrie team also partnered with the Florida Institute for Human and Machine Cognition to implement their walking algorithms on NASA hardware in preparation for the Space Robotics Challenge, part of NASA's game-changing development program and Centennial Challenges. Valkyrie is a 1.9 meter tall, 125 kilogram, 44 degree of freedom battery-powered humanoid robot. The challenge created by DARPA involves tasks like walking over uneven terrain, climbing a ladder, using tools, and driving. This means that Valkyrie has to be capable of operating in the same spaces that a person would operate in, under the control of humans who have only minimal training with robots, which is why the robot's design is based on a human form. The overall goal of the DRC is to help drive innovation towards robots that are able to take over from humans directly without needing any special accommodations. As revolutionary as the technology inside Valkyrie is, and as important as the robot is the future of space exploration, the team's focus on design as well as engineering has made Valkyrie into something more. Number 6. Astro. Astro works as a smart display, a roving security guard, a toy for the kids, and an errand bot. And all those features are built on an innovative piece of hardware. For now, this robot remains a luxury item for people with a lot of money to try out a cutting-edge technology that still lacks a compelling use case. And that's not necessarily a bad thing. Amazon's Day 1 editions are, after all, experimental projects, and the development team is still working out Astro's flaws and honing its features. Amazon's Astro looks a lot like an Echo Show 10 smart display on wheels. It has the same 10.1-inch screen with a 5-megapixel camera on the bezel, which lets you video chat, albeit from a bit of an awkward angle, and two front-facing 55mm speakers with a passive bass radiator. Because Astro is so low to the ground, it also has a way to change its perspective. A periscope which emerges from the swiveling head of the device near the mute and volume buttons adds a 12-megapixel camera and an additional 5-megapixel camera. Of course, what sets Astro apart are the wheels. The development team at Amazon adapted navigation technology, long used for robot vacuums, to help Astro efficiently map your house, then navigate smoothly and efficiently when given simple voice commands like "go to the bedroom" or "take this drink to Andrew in the living room." Amazon Astro is an ambitious device, both fascinating and frustrating. And it's a pretty incredible step forward for smart home technology, if no other reason than that it's a robot you can actually buy and use in your home. Number 5. Pepper. Developed by SoftBank, Pepper is a genderless, chatty, childlike humanoid robot already on the market. With a price tag of less than $2,000, Pepper is the first social humanoid robot to hit the mass market. It is short, made of shiny white plastic, and rolls on wheels. It has big black eyes that flash with blue light. He is designed to resemble a child and was created to become a member of the family. Pepper recognizes a range of emotions, from joy to sadness, anger to surprise, and adapts its behavior to the mood of humans around. It comes with a 3-year warranty, and the buyer must sign a user contract promising not to use Pepper for the purpose of physical or indecent behavior. During COVID-19, Pepper was taught to be a receptionist in hospitals, greeting patients, taking temperatures, and enforcing hand sanitizing. In more of a therapeutic role, Pepper has also been deployed to ease loneliness in elderly patients amid shortages of nurses. Standing 120 centimeters tall, Pepper has no trouble in perceiving his environment and entering into a conversation when he sees a person. The touchscreen on his chest displays content to highlight messages and support speech. His curvy design ensures danger-free use and a high level of acceptance by users. Number 4. Paro. Paro, a special robot that has been around since 2003, is a cuddly baby harp seal robot. Paro is a therapeutic robot designed to elicit warm emotional responses and have a calming effect on patients in hospitals and nursing homes. It is furry, its whiskers respond to touch, and it responds to petting by fuzzy tail wagging and cute fluttering of its eyelashes. Paro also responds to sounds and can learn names and faces, including its owners and its own. You may have seen Paro on Aziz Ansari's Netflix show Master of None in an episode aptly titled Old People. Paro also hit pop culture during an episode of The Simpsons in which Bart Simpson creates robotic baby seals named Robo-Pets to cheer up the residents of Springfield's retirement castle. The episode was titled Replaceable You. Paro is meant to function similarly to a therapy animal. In some ways, it's better. It can help with anxiety, depression, and loneliness, but it doesn't need to be walked or fed, and it never gets sick or dies, and it works. Number 3. Robear. The Japanese government has funded the development of different kinds of robots in elder care facilities, such as robots that can lead patients in Tai Chi and can support physical therapy and rehabilitation. Here comes the Japanese Robear, a whitey shiny robot that can lift patients and carry them around. It's a primal, animalistic robot that uses advanced technology to power its intelligent vision, flexible movement, and giant arms strong enough to lift a human right off the ground. It could have profound implications for the relationship between man and machine, but perhaps most importantly, it is very cute. Robear is an experimental nursing care robot developed by the Riken SRK Collaboration Center for Human Interactive Robot Research and Sumitomo Riko Company. Unveiled in 2015, the robot is designed to lift patients out of beds and into wheelchairs, as well as helping those who need assistance to stand up. Robear weighs in at 140 kilograms and is the successor to heavier robots Riba and Riba 2. Number 2. AO. AO is a service robot made by Japanese company ELON'S Robotics. The company says its bot can be used for security, delivery, healthcare, and hospitality purposes. AO has 2 arms, one outfitted with grippers to pick up objects, open doors, or press buttons, and the other fitted with an L-shaped UV attachment to disinfect surfaces. Its 360-degree night vision camera can monitor a home, office, or other space and stream live video to your phone or laptop. Its care function can detect when patients are in distress or at risk. It's relatively compact at 3.8 feet tall by 1.8 feet wide, and its arms can lift up to 8.8 pounds, so it won't be helping any patients up if they fall, but it can bring them food, drinks, or other supplies. AO is already in use in airports, hotels, and hospitals in Taiwan, Hong Kong, and Japan. Number 1. Parky. Evar's Parky robot was made to help electric vehicle owners get their car batteries recharged faster and with less hassle. As EV adoption grows, tools like Parkey could become helpful as drivers try to navigate an as-yet slim charging infrastructure. Rather than having to park at a charging bay, drivers can park anywhere in a lot and have Parkey come to them. The bot provides 15 kW DC charging per hour, juicing vehicles up with about 50 miles of range. The catch is that drivers still have to find a spot next to an EV robot connector and plug in. So depending on supply-demand ratios, Parkey may not make much of a difference in terms of convenience and speed. The robot makes the most sense for buildings that want to make their parking lots more EV-friendly without undertaking construction or redesign work or having to add electric capacity. That's all for today's folks. See you next time.